Hi
Yes,
guys,
sir.
good evening. Hope everybody is able to hear us.
Yes, yes.
Thanks, Zahir. Guys, there's uh, slight delay in the class. We are just connecting. Meanwhile, we request you all to send the same link to uh, your friend which you're connected just now because there is some issue with yesterday's link. So we have created a new link, and I request all of you to please share this link to your friends to join to the session. Thanks for your patience. We'll just connect back in 2 minutes. Thank you. Manjunath, you there?
Yeah.
Yes, Manjunath, we can hear you. Um, so, guys, as per our plan, let us start with the discussion today. I mean, you had many questions yesterday, so most of you had many questions yesterday, so we can start working on the questions. Zahir, please help Manjunath to read out the questions and he will answer the questions till the time being. Thank you,
Sure,
guys.
sure,
You can
Bhargav.
post your questions. Guys, you can post your questions in the chat box as well as you can raise your hand. We will unmute you and you can speak up then. That would be better. Please raise one by one. We will unmute you and you can ask the question simultaneously. I request all of you to please bear with us, maintain the accuracy so that it will be easy for us to answer everybody's queries today. Okay, we'll take the sessions up till first half an hour for the easy understanding of yesterday's session. Thank you so much. Please ask your questions, everybody. Zahid, please go ahead. Thank you. Zahid, you're there? Zahid, you're there?
Yeah, I'm
Guys,
here.
yeah. Guys, please, you can post your questions on the chat box. So yesterday we have discussed about basics or why we require ED. Manjunath, you're there. Can you please brief them what you've discussed yesterday?
Shall I start? Can I quickly recap the things what I have discussed in the last class?
Yes, please.
I
You
think
can do
no
that.
one is spoke. Okay, guys. Good evening for everyone. Welcome to day 2 of 5 days masterclass in electrical technology. Then we have seen two topics. Let me quickly recap the topics. Uh,
Sorry, Manjunath. Sorry to interrupt. Actually, your voice is not clear.
I'm waiting doubt from your side. Uh, okay, getting any doubts from you?
Manjunath, your voice is not clear actually.
Hello, now you people can hear me.
Yeah, Manjunath, you can continue.
Yeah, now can you hear me?
Yes, yes.
Yeah. Okay, sorry for the inconvenience. Yeah, so if there is any info, please let me know. Yeah. Coming for the quick recap of the last session. In the last session, we have started with a basic introduction to electric vehicle, in which where we have seen the latest trends in the EV technology. So coming to the latest trends in the EV technology, we have seen what are the ongoing trends like electric mobility promotion scheme. Regarding electric mobility promotion scheme, we have seen. Then we have seen what is the share market in the EV sector compared to different markets. Then we have seen where the Tata is leading the industry. We have seen regarding then we have seen regarding that. Later, we have seen something called our two-wheeler segment, how the two-wheelers are rising in the market, what is the percentage of individual firm in the two-wheeler segment, that we have seen. Followed by then quickly we have seen what are the advancements happen in the EV technology. In the advancements, we have seen there are AI-powered vehicles. So before I go into the advancements, yesterday I have given some assignment. Can you quickly say what is the assignment given by me? Yeah. So the assignment given by me is disadvantages regarding the electric vehicle technology. Now here comes the answer for the yesterday's assignment. Can you people quickly post the answers in the chat box? I'll give the time of 2 minutes. So whatever the drawbacks you found, you can quickly post in the chat box. I'm waiting for your answers. Come on, guys. This is early of the session. I'm waiting for the responses. I want the enthusiasm in you people. So quickly respond. As I said in yesterday's class, that may be correct or that may be wrong. Quickly give me the attempt for that. I have nearly 250 participants. I want at least 250 answers right now.
Actually, Manjunath, Satya said that disadvantages are limited range, high upfront cost, and
I'm seeing
concerns about.
regarding the advantages. Once
Yeah,
I'll conclude all of them and I'll let them know. So
sure,
before
sure,
I'm
okay,
discussing with them, let them.
sure.
Yeah, Tilak, every answer will be checked. No need to worry. I am waiting for the others' answers. So we are having nearly 250 plus participants. So let everyone answer. Let everyone get the opportunity. Yeah, very good, guys. I got most of the answers. So I'll give some more time. By then you can post. Then whenever we go into the topic, I'll let you know what are the disadvantages, main disadvantages, what need to be focused. Now, coming back to our topic, which we have discussed in the last class, where we have seen the AI powered vehicles as introduced in the market. So I can say that in case of the AI powered vehicles that introduced in the market, we'll be having the health checking opportunity. So I think all of you are aware of the artificial intelligence. What is the role of artificial intelligence in our day-to-day life? How it is playing the key role. We are aware of that. So whatever the segment you take, in every segment, we'll be having at least some or other impact of the artificial intelligence, and where we discussed regarding the industrial revolutions. That industrial revolution itself saying the fourth industrial revolution itself says that that revolution happened because of the communication and AI technology, where we'll be having the big data, where we'll be having few other different technologies like cyber security, industrial automation. We'll be having the Internet of Things. So everything is embedded into one segment, and every segment is booming by using all these technologies. Yeah, that technology has introduced into electric vehicle also, where if we properly check the vehicles, if I'm not wrong, if you check the Tesla vehicles, where the Tesla model S vehicle, or you can go for the Tesla, one of the Cybertruck vehicle, whatever the vehicle we are taking, most of the Tesla vehicles now they are targeting for the unmanned ground vehicles. So as we see that in yesterday's class, we have seen that unmanned ground vehicle is something the vehicle is running without any driver. So this is one of the shocking things for us because we are habituated for that where even the drivers are there, there are lots of accidents. So general గా మనం చూసే సినారియో ఏంటి అంటే డ్రైవర్స్ ఉన్నా కానీ మనకు చాలా యాక్సిడెంట్స్ అవుతుంటాయి. Even drivers are using their own brain. Okay. So even though there are some disadvantages, but whenever you are coming for the AI fed vehicles, they don't have any such disadvantages because the added human brain is integrated with the artificial intelligence, where the data, the data is, the data will be having the computer vision very good. So that data is properly, that vehicle is properly made with the preloaded data and the existing data, where you will be having all the preloaded data given for the vehicle. And for those vehicles, by default, we'll be having the radars. By default, we'll be having the cameras. By default, we'll be having the sensors. And all these radars, sensors, everything is induced into one technology, is induced into one central processing unit. From there, the vehicle will be running properly. So in the recent podcast, I seen one of the ad that one fellow is saying that one of his friend is booked some cab in the US. Where he's sitting in the vehicle. So whenever he's traveling in that driverless vehicle, suddenly rain has started. So whenever it's highly raining, the passenger inside the vehicle can't see the road outside, but the vehicle is running properly. The vehicle is running very accurately. The vehicle is running very efficiently. Okay. See, the point is that even human can find some mistakes. Even human can have some mistakes. But when this AI is included into it, there is very, very, very minimal scope of mistakes. There is minimal scope of problems. And we'll be having different types of sensors. Let us know what are the different types of sensors and all in the further sessions. No need to worry. Then whenever we are dealing with the AI powered vehicles, if I'm not wrong, these ADAS technologies are also introduced in the Indian vehicles, Indian scenario vehicles. So if you properly check the Indian scenario vehicles, there are few vehicles where the ADAS technology is included, where the artificial intelligence is included. I read one article where it is saying that the driver safety assistance is there in that vehicle. So if any driver is getting any sleep and all thing like sleep, the camera kept nearby steering will identify the movement of the respected driver. It will be giving if the driver is sleeping, automatically it will be giving the indication saying that some buzzer sounds will be coming. So here, the point is that one more thing, if someone is asking when he went to the other country, I don't know when he went to the other country. I'll try to ask him and I'll let you know definitely. Once if he says, definitely I'll let you know. No need to worry. Then someone, Tilak is saying that AI can also help with the security monitoring. Very good, Tilak. Accident response for the vehicles and charging networks alike. Everything you'll be having the deep learning. The point is that I'm not presenting any screen and no need to worry because when I'm quickly recapping the classes, I don't present any screen. You just no need to worry. You try to listen, you try to summarize the points, because if I present the screen, then automatically your focus will be completely on the screen itself. So you can't brainstorm yourself. So if I'm directly talking, if you listen the last class properly, then you try to brainstorm where that slide I have seen, what the things I have seen in that slide, that we can brainstorm. So that's what I'm saying. The screen means the PPT itself. Coming back to my point, where I stopped. Guys, where I stopped. See, the point is that that's what I'm trying to explain. Whenever I'm quickly recapping the things, I'll not present any PPT, Andy. You just stay hold. First, you memorize the things what we have discussed in the last class. use your book, use your pen, where you use them for writing the running notes and all. So I have stopped in the driver monitoring system. I have stopped near the driver monitoring system. So yeah. Can anyone say, are there any unmanned vehicles in Indian scenario? Can you quickly say, are there any unmanned vehicles in Indian scenario? Are your old vehicles or unmanned vehicles? Do we have any unmanned vehicles in MG? Someone is saying Tesla. Do we have any Tesla cars in India? Yeah, if any Tesla car is there in India, please let me know. I'm very much interested to drive the Tesla car, because without driving, the car will be moving. So if there are anything is there, the point is that I'm not asking about any Hyperloop vehicles and all, because they are in R&D stage itself. The only thing I have asked is, are there any unmanned vehicles like Tesla in India? So most of the people are saying no, and some people are saying the metros and all, how metro can run without a loco pilot. Mahindra is EV car, I don't know that, but is Mahindra is unmanned electric vehicle, where the car need to run without any driver, or it should run based on the AI technology you are using. No roller coaster. Very crazy. Roller coasters, giant wheels. I think we can't consider them as the electric vehicles. So if anyone sees these answers, they'll say that they'll just laugh it. No, then MG Goldstar, not exactly. Hyundai, we don't have any unmanned in Hyundai. Not Tesla, but most advanced in Kia E6 BYD EV cars are present in India. Are those cars are unmanned? Yeah, someone is saying that no proper unmanned vehicles we are having. Yeah, that is the partially correct. Then Mahindra XCV, not it's not. I think it's XUV. I mean Bullock sir. Bullock see, that is also manned vehicle where we need to give the signal. I think yesterday you only asked that question. Do we not use any man energy? Yes, here we do not use any man energy, but we use the man instructions given by the human being. Then Tata is planning very good. Tata is planning. Everyone is planning. They need to plan. Yeah. They need to plan. Okay. Them let the planning is happen. AI technology is coming. Yeah. Okay. I think most of you people tried to give the answers. I'm very happy for that. But coming for the question I have asked is I can say that as of now we don't have proper unmanned ground vehicles. Okay, but India has developed and deployed few research-oriented unmanned ground vehicles, which are known as your Daksha. Okay, Daksh, which is designed by DRDO and which will be used for bomb disposal and any hazardous material are there. There will be using. Then something called your next oriented RoboSen, which is developed by DRDO itself again. And L&T is also into the unmanned ground vehicle segment where they are also trying to develop. But as of now, I can say that we don't have any proper unmanned ground vehicles. Right. See, the point is that definitely in future it will come. Okay. In future it need to come because whenever the technology is growing up, we need to grasp the technology. So that is what the point. Yesterday we have seen that where the EV market is where the automobile market is properly trying to establish the EV market because they are in R&D. See, I'm not asking about the possibilities. Okay. See, if we think about the possibilities, we may get the Hyperloop vehicles also. And one thing, one of our friends said that one of the IIT has working on the Hyperloop. So where where one of the company one of the students or one of the set of students has started working on this Hyperloop technology, where very soon they may start this. It may take some time. Yeah. So that is what regarding unmanned vehicles. Any other answers can I from your side, or shall we move into the next segment? Hyperloop can go up to 2000 kilometer per hour, but due to issue, they are limited to 1050 kilometer. Yeah, see, the point is that where we are trying to create the tracks and all, those are not up to the mark. Now, as of now, we are only having the Hyperloop vehicles up to 1050 only because they are still in R&D. We may get the 2000 kmph and we may get somewhat extended also. That is not the bigger task, if I'm not wrong. Yeah. So the point is that I'm waiting for any other answers because as per schedule, daily 7 to 7:30 will be your questionnaire section or some discussion section. Then after I can start my class. Even though if there are any questions also, I'm open for that. Yeah. So before going into the topic, yesterday I have asked you people to connect us in the LinkedIn. How many of you people connected us in the LinkedIn? Can you quickly post S in the chat box? Yes. Yeah. How to create the LinkedIn? Just you can go to the Play Store and you can download the LinkedIn From there, you can create your account. Okay. Yeah, just you can easily do that.
Recording in progress.
Yeah. Yes. Just a minute. Yeah. Okay. What about the remaining people? How many of the people don't even have LinkedIn account? Yeah. So for the some of the people is saying that you want our LinkedIn ID. Our team members will post the HIW's LinkedIn ID in the chat box from where you can check it, and from where you can connect us in the LinkedIn. So the advantage with LinkedIn is I think all of you are aware of the what we say Instagram and all. So we are the people where we'll be using the lots of Instagram. So the point with the LinkedIn is whenever you are coming for the Instagram, it is something called our personal platform where I'll be posting everything. Today I went to the Goa. Today I did this. Today I did that. Everything you'll be saying. But whenever you are coming for the LinkedIn is something that where it is official platform where you need to post all your day-to-day official updates. So now you are attending for the EV masterclass. So you can just have a screenshot of it. You can post it down the stream whenever if any HR is going through your LinkedIn profile, or if anyone is going through your LinkedIn profile, they'll get to know that you have attended for so and so sessions, you have attended for so and so webinars, you have attended for so and so seminars. So which will create a lot of impact that you are trained in that segment, you are aware in that segment. So it will be one of the career booster for you people. So now guys, can you hear me properly? Yeah, can you see my screen? Chalo. We have seen the different trends in the electric vehicle segment in the last class. Then followed by we have seen the industrial revolution, different industrial revolution, what happened in the industrial revolutions, how the timeline has begins and all we have seen. Then we have seen the history of the vehicles, how it started, how it is going and all. Then we have seen the definition of vehicle. Can you quickly say me what is electric vehicle? What is a vehicle? Uh, which transports the things. Then what about the rest of the people? Move to place. It is a machine that used to move from one place to another place. Yeah, a vehicle is a mechanical design. Yeah, very good. So yeah, so Chal. Now, a vehicle is a means of transport where you can sit and travel from one place to another place where the means is running by wheels, and which the wheels need to have the power from the power source. The power from the power source is transmitted towards the wheels. So this is the thing we have seen in the last class. Then we have seen the bullock type of vehicles and all. chalo, let's quickly go into the thing where we have stopped in the last class. If I'm not wrong, we have seen regarding the pollutions and all. Then we have stopped at the point what are the advantages of electric vehicles. If I'm not wrong, yeah, coming for the quick advantages of electric vehicles. Yeah, here we'll be having the quick advantage of electric vehicles, where it will be saving the money on the fuel cost. It will reduce the emission. It will reduce the oil usage. We don't have any noise emissions in case of the EVs. We will be having the proper regenerative stopping, more efficiency or more energy efficiency we'll be having. EVs are innovative and smart. We will be having the proper, simpler drivetrain. And we'll be having the low running cost. Okay, so this is what we have seen. Then again, now before going into the disadvantages and all, let us see what are the components of electric vehicle. Let us see what are the components of electric vehicle. So whenever we are coming for the components of electric vehicles, in the electric vehicle, the major components we will be having are traction battery. Then we'll be having something called your DC to DC converter. Then we'll be having something called your traction electric motor. Then we'll be having something called power inverter, then charger port. Then we'll be having the onboard and outboard chargers. Then we'll be having something called our controllers. Then we'll be having the auxiliary batteries, then thermal system and the transmission. So these are the major components. Whatever the vehicle you take, we'll be having. So if we properly dissect the individual concept or individual component, then we'll be getting a lots of information from that, and which will help to design the vehicle more accurately, design the vehicle more easily. Because see, the point is that whenever we are trying to learn the new concepts, or whenever we are trying to get awareness on the new concept, the one thing we need to do is we need to get very proper basics. Okay, we need to get very proper basics regarding it. Yeah, chalo. Now let me explain all the individual components. See, these are the very important components. If you don't have clarity regarding these components, then definitely we need to think about the EV once again, because without knowing these concepts, we can't move any further into the EV technology. Yeah, chalo, let us start with the traction battery pack. I think everyone can see my screen if I'm not wrong. Yeah. So coming to the traction battery pack, the traction battery pack's function, it is a function of the function of the traction battery pack in an electric vehicle is to store the electrical energy in the form of direct current. Okay, this you need to remember. Here the traction battery pack will be storing the electrical energy in the form of direct current. Okay, that is your DC electricity. Then here the point is that whenever we have seen the vehicle, we need to control the speed of the motor for controlling the speed of the vehicle. Now, to control the speed of the motor, the input power given by the battery need to be controlled. Now, whenever I need to control the input power, there should be some mediating equipment in between the battery and motor. That is the controller. So what happens in case of the battery will be storing the electrical energy in the form of direct current, direct current electricity. Then whenever it is getting signal from the controller, the battery will allow to flow the DC electrical energy into the inverter to be then used to drive the motor. Okay, see, the point you need to be clear, you need to be very much clear here is the battery never directly connected to the motor. Okay, yeah, because when if the battery is directly connect to the motor, then is there any issue with my presentation? I'm getting few queries regarding the presentation. No. Yeah. The slides
Manjunath,
only.
it is
benefits.
not on the presentation mode, no?
Yeah,
So
I'm
they are
checking.
just
Fine. Yeah. Let me check it quickly. Now I think it's clear. Yes. Can you see the slide which is showing the traction battery pack? Yeah. Yes. Okay, chalo. So here the slide will be dealing with the traction battery pack, where I'm trying to explain you people that the battery pack in the electric vehicle will be storing the electrical energy, which is in the form of the direct direct electric current. Whenever it's getting the signal from the controller, see here initially the controller will be getting signal from the driver, which is our driving unit. So these are the things you need to remember, because these are the things which will be reflected whenever we are doing the simulations and all. Then the controller will be sensing or will be giving the signal to the battery. Then the battery will be flowing the DC electrical energy into the inverter. Here we can go into the inverter, or we can go into the we can simply say that we'll be having the converter. So based on the different modes, it will be changing. Now the type of the battery is rechargeable here, and here I can say that it is made up of the now the battery is made up of the several cells, where which will be know you'll get to know in the battery chemistry. So in general, if we take a proper battery pack, it consists of modules, and if we take the proper module, it consists of cells, and this is how the battery chemistry looks like. So whatever the battery we are seeing, whatever the DC battery we are seeing, we'll be having the plus and minus terminals. It don't indicate, or it is not indicating that we'll be having only one cell which having plus and minus. Inside the batteries, we'll be having a number of cells, depends on the output we need to require, and those cells will be connected in series and parallel based on the power output we need to extract. That is something different story. But whenever we are coming for the traction battery pack, this is the application of the traction battery pack. So you need to be clear that you should never connect the battery directly to the motor, because if we connect the battery directly to the motor, then the motor will be running at the maximum speed, and for the motor you will be having the high inrush of current. So I think all of you are aware of your OCSC test, where you will be using the 3-point starters and all. So those starters are in generally used to reduce the high inrush of current. In the same manner, here, if we don't control any, if we don't connect any controllers and all, it will become very difficult to control the motor. So then the motor will not run properly, and which may lead to the burnings of the windings and all. There will be a lots of issues we'll be having. So before connecting the battery to the motor, we need to have some controller which will be helpful for the smooth operation. Then we need to have some converters. Okay, chalo. Then whenever we are dealing with the traction battery packs, in generally, most of the battery packs, or typically the battery packs, is made up of the lithium ion batteries, because of their advancements in the chemistry. And whenever you are considering the lithium ion batteries, they will be having the high energy density, and they will also be having the high power to weight ratio. So these are the very salient features of the lithium ion batteries, which made the lithium ion batteries to observed by electric vehicle market. Now, whenever we are coming to the voltage of the traction battery pack, it is usually provides a high power. Okay, so whenever you are dealing with the traction battery pack, it usually provides a high. It is usually provide the high power. Now that power is measured in generally in the kilowatt hour. But here one thing you need to remember is, in the vehicle, battery is not the motor is not only one electrical component we need to consider. Along with the motors, we will also be having a lots of auxiliary components that need to be powered. For that, we'll be using the DC to DC converter. Very soon you'll get to know. Now, here we need to know that higher capacity generally allows the long driving ranges. See, this is what we need to remember, that the point is that whenever we are discussing with the EVs, most of the people will be saying that by using the EVs, I can't go for the long drives, I can't go for the long rides. The long rides will be breakdown if I am using these EVs and all. Yeah. Someone is asking to go slower. Yeah, I'll go slower, Andy. Okay, yeah, chalo. So the point is that whenever you're dealing with the traction battery pack, they'll be having in generally the high voltages because see, it depends upon the variant to variant. Mostly I'll be focusing on the four-wheeler vehicles. If you are clear regarding the four-wheeler vehicles, then two-wheeler vehicles designing and all will be a cakewalk for you people. So the point is that in generally they'll be having the high capacities
Vinod, sorry
because
to interrupt you. You're on traction battery pack and everybody is asking you to change the slide. Could you please you're on the same?
madam, yeah, I'm on the traction battery pack where it is showing the voltage ranges from 350 to 800.
No. You're only on the basic, just the introduction of the traction battery pack. Can you go to the
Now,
please?
now is it okay, ma'am?
Yeah, it is. It is saying that 350 to 800 volts. Correct.
Yeah, this is the slide. Yeah. Okay. Chalo, so this is the
Okay,
slide.
You sorry to interrupt, Manjnath. Can
Yeah.
you go little slow? You're too fast for everybody to
Okay.
understand.
Okay,
That
ma'am.
is
Sorry.
useful.
I'll go a little slower.
Yeah. Everybody is
Chalo.
like going on little fast. You're going. Thanks.
Okay. Done. Yeah. So I'm waiting for any inputs. Okay, now I'll go a little slower. Chalo. So yeah. Now the slide is okay, no? Where I'll be having the traction battery pack. Yeah. So from this, I'm trying to say you people that the voltage will be varying from 350 to 800 volts. This is for the typical voltage of the traction batteries for an EVs or HEVs in case of your four-wheelers. Whenever we are coming for the two-wheelers, in generally we'll be going for the 72-volt batteries. We'll be going for the 96. We'll be going for some very low, less than 250. Because most of the two-wheelers nowadays in the market we are having are the low speed vehicles, followed by we are also having few high speed vehicles where they are also having the maximum of 5 kilowatt hour battery, 6 kilowatt hour battery, which is 72 volts battery is more than enough. Then whenever you are having the batteries over 300 volts with the capacity of 20 to 60 kilowatt hour, then the expected range will be 450 kilometers. Okay. Now, if anyone is asking that I'm getting the vehicle range as 500 kilometers, what might be my battery range? Okay. Then approximately you can say that the voltage will be varying from 300 to 500 and we'll be having the battery capacity in between 20 to 60 kilowatt hour. That calculation and all, I'll let you know how to do. But basically, this is what you can randomly say because as an electrical engineer, if anyone asks, we need to say some rough figures. Which may not be appropriate, but which should be equivalent to that. Okay. Yeah. Then this is how the traction battery pack in an electric vehicle you can looks like. So here you can properly see that if this is the traction battery pack. So in generally, whenever we are going for the passenger vehicles, can you see the battery pack here? Yeah. So the point is that whenever you are dealing with this type of the batteries, so here you can observe in case of the passenger vehicles, the battery packs are usually located along the floor plan. Okay, if you properly check the battery packs and all, in case of the passenger vehicles, usually they are located into the floor plan. But whenever you are coming for the commercial or public transport, EVs will be having the multiple batteries where they are located in front, rear, and even they are located in the roof also. So this designing will be changing based upon the variant to variant, but the proper appropriate variant for the passenger vehicles will be this, because see, the point is that whenever I am going for the hybrid vehicles, in case of the hybrid vehicles, I need to place the battery, I need to place the engine, I need to place all the mechanical part. Even though whenever I am coming for the electric vehicle also, here the components I need to place are my batteries, which are my traction batteries. Then I need to have my motors, I need to have my controllers, I need to have my converters. Along with that, I need to have one small battery, that is my auxiliary battery. So all these things need to be fitted into the passenger vehicle. So the suggestible method is to place the batteries on the roof plan. So yeah, this is about the traction battery pack. Now whenever you are coming into the proper battery pack, a battery pack must have the efficient effective cooling and proper temperature distribution. Because here I need to add one point that so many people are saying that my EVs are blasting, or there are few blastings in the EVs and all. In the initial stage, there are few disadvantages with the EVs also, but later on the proper cooling system is introduced into the EV technology. The proper temperature distribution system is included into the EV technology, which I can properly say that there is no major constraint regarding the heating issues and all. Because if I'm not wrong, I have seen one of the local variant vehicle where whenever we are driving on the vehicle, if the battery is getting heated, automatically initially for the 5 minutes, it will be giving the signal. Okay, then after 5 minutes, wherever you are going, automatically it will stop the vehicle on road. Because see, the first signal will be indicating you that you need to stop the vehicle because the heating level is exceeding. Now coming for the heating levels, most of the batteries we are using are the lithium-ion batteries. Coming for the lithium-ion batteries and all, they can withstand the temperature levels up to minus 40 degrees to 60 degrees, which are the safe operating area. So if we are exceeding that safe operating area, then initially we'll be getting the indication, then automatically there will be the proper stopping of the vehicles and all. It depends on the variant we are using and how it is happening and all. You'll get to know while we are discussing the battery management system. Now, if we take an illustration, a traction battery pack with 16 modules and 7104 lithium-ion cells is the most popular battery pack offered by the Tesla. Because whenever you are going for the Tesla vehicles, mostly we don't even have any range difficulties. Okay, we don't even have any range anxieties. Okay, so yeah, mostly we don't even have any range anxieties. Yeah, is my screen visible? Someone is saying yes. The screen I am presenting is battery pack. Yeah, if anyone is getting screen issue from your side, you can disconnect and connect for the session again, because the connectivity from my side, I think it's proper. Yeah. Now, whenever I'm coming for this type of example, where I'll be having the 16 modules in which I'll be having 7104 lithium-ion cells. This is one of the most popular battery pack which is offered by the Tesla. So if you properly calculate this battery pack, this module can store up to 85 kilowatt hour of energy. Okay, this can store up to 85 kilowatt hour of energy. Okay, from there we need to calculate what is the voltage rating and what is the ampere hour rating. It depends. We need to calculate. It depends on the calculation criteria we are selecting. Further, I'll let you know how to calculate that. Now, whenever I'm coming for the proper lithium-ion battery, I need to have the nominal voltage of the cell is 3.7 volts per cell, and the nominal ampere hour rating or the nominal current rating should be 3000 milliampere, and one cell can withstand up to 3000 life cycles. Okay, 3000 cycles, which includes the charging and discharging. Okay, so if you are using your battery properly, if you are charging your battery properly, and if you are discharging your battery properly, then definitely you'll be getting nearly 3000 cycles if you take a proper battery pack. Yeah. Then the point is that if you properly observe that the same lithium-ion pouches or lithium-ion battery packs, battery pouch model batteries only we are using in our mobile. So just I'll give the example of your mobile itself. So initially, whenever we are buying the new mobile, we are very much excited for that. So initially, the mobile phones will be giving the state of charge, versus time ratio. If you take, it will be coming nearly 10 hours to 12 hours if you full charge your battery. Even though if you are working, even though your mobile battery is working on the full load condition, also it is withstanding up to 10 hours. But later on, what happens slowly, slowly the capacity is getting decreased. Slowly the capacity is getting decreased. Okay, now the point is that what happening here? Here the number of life cycles of battery is getting reduced, and see, the point is that battery need to have proper 3000 life cycles. But if we are making the battery improperly, if we are charging and discharging the batteries improperly, then automatically the number of life cycles will be reduced. So, okay, so this is the thing we need to remember, even in case of the electric vehicle batteries or in case of the any mobile batteries. Okay. Yeah.
Now the next component we'll be having is something called our DC-DC converter. A DC-DC converter is a crucial component in the electric vehicle. It is a device which converts the direct current from one voltage to another voltage, where I can say that buck or boost converters we can use here, which are the DC to DC converter. Now, the use of the DC to DC converter in the vehicle is in generally EVs will have multiple voltage levels within their electrical system. Okay. Now, if I take my electric vehicle, imagine my motor wants 300 volts of voltage capacity. Then my battery is also supplying equivalently 300 volts of supply. Okay. So imagine the same 300 volts. If the same 300 volts is given for your lights, if the same 300 volts is given for your horn, or if the same 300 volts is given for your sensor, then automatically what happen? They can't withstand that high level of voltage and they'll get damaged. Okay. So here what we need to do, we need to step down the existing voltage level to the voltage level where we'll be having to the required voltage level, we need to step down. Okay. One method what we can do is we can step down with the help of the DC to DC converter, or one more method what we can do is the traction battery pack operates at high voltage levels, while other components such as 12 volts auxiliary system requires low voltage. So here I can also go for the auxiliary battery, or I can go for the DC to DC converter. Okay, so this is the use of DC to DC converter. So simply you can say that the DC to DC converter is used to supply the power for the auxiliary windings. So if you have the proper electrical two-wheeler, if you remove the seat of the electrical two-wheeler, then you can easily identify you will be having the hub BLDC motor, where the hub BLDC motor is connected to the controller. Okay, now this controller is connected to the motor. From there, the application of the motor and battery will be running. But whenever you are opening the front part of the vehicle, there you will be observing some 12 volts DC to DC converter or 15 volts DC to DC converter. Those are the converters where they are used as step down converters. They'll be stepping down the typical voltage given by the traction battery pack, and that voltage levels is supplied for all the auxiliary system. Okay, see, this auxiliary battery you can also find in your normal two-wheeler vehicles also, where you'll be having the 5 volts batteries, 10 volts batteries, which will be acting as a auxiliary battery packs. Okay, yeah, I will discuss regarding the auxiliary battery packs. Coming for the DC to DC converters, instead of auxiliary battery packs, we can also go for the DC to DC converter, which will change the voltage level from one level to another level. Now the next thing we'll be having is something called our power inverters. So in case of the power inverters, if you properly observe, in generally the power output we'll be getting from the batteries are DC. If you take the different types of the motors in electric vehicle, except the BLDC motor, all the different motors are running only on the AC input current. Okay, they'll be running only on the alternating current. Now I need to convert my DC power into the AC power, or DC current into the AC current. So here, for this case, I'll be having inverter on an electrical car, which has the function to change the AC current into DC to AC in case of the normal application, and which will also help to change the current from AC to DC in case of the regenerative braking. So in generally, the inverter we are using here is bidirectional inverter, or we can also go for the multi-level converters here. Okay, so this is the use of the bidirectional inverter or multi-level converter, which will be converting the DC to AC or AC to DC. Okay, so DC to AC need to be converted whenever whenever I am getting what we say whenever I am getting something called my normal application, and AC to DC need to be converted in case of the regenerative braking mechanism. Okay. Or else we can go for the generator, which will be giving the DC output. So that is something difficult mechanism, which will increase the weight of the vehicle, and which may also increase the burden on the vehicle. Let us keep it aside. So this is the use of your power inverter. Okay. Now, in case of the power inverters, they are specifically designed, and here you will also be having the three-phase inverters and all, which will be used for your permanent magnet motors, and which will be used for the three-phase induction motors. So you will get to know what are the permanent magnets motor, what are the switched reluctance motor, what are the DC motors, what are the BLDC motors and all. In tomorrow's class, if I'm not wrong, you'll get to know Yeah, this is how you'll be having the converter unit in between the source and battery, and also in between the battery and motor. Okay, so if this is the grid to vehicle and vehicle to grid technology, this is how the AC to DC and the DC to DC converters we need to use, because whenever we are converting the AC power into the DC, by default we'll be having some what we say some ripples or some distortions in the DC circuitry, then automatically that need to be converted into, yeah, we'll be having some pulsatings in the DC circuit. That pulsating DC need to be converted into the pure DC. For that, again, I'll be going for the DC to DC converter. So that is regarding the converters which we are using in generally. Then next is our controller. So can you see my controller screen? Can you quickly respond? Yes. Yeah. Okay, chal. So whenever you are coming for the controllers, the main function of the controllers is it will be working as a regulator of the electrical energy from batteries and inverters. Okay, so this controller will be acting as a regulator of electrical energy, which will be getting from the batteries and inverters that will be distributed to the electric motors. That will be distributed to the electric motor, while the controller itself getting the main input from the car pedal. So here, if you see this one, this is the thing happens in case of the controller. So controller is the main thing which will be getting the input from the pedal. So whenever you are coming for the driving modes, you will be having the acceleration and deceleration modes. Okay, so whenever you are having the acceleration and deceleration modes, so these acceleration and deceleration inputs are directly given to the, this acceleration and deceleration inputs are directly given to the controller. Okay. Yeah. If you properly observe here, the pedal inputs will be directly given to the DC controller itself. So this DC controller will be getting the input from the batteries, or this DC controller will be giving the inputs to the batteries. Then in between, we will be having the converters that will be giving the signal for that will be transmitting the power towards the DC motor. Okay. So this is not the exact figure. In between, we'll be having the dependent voltage sources. We'll be having the dependent current source to measure the current. One dependent voltage source will be acting as a acceleration pedal. One dependent voltage source will be acting as a deceleration pedal. Everything very slowly you will get to know, or whenever we are dealing with the simulation, there you will get to know the proper clarity regarding this. Now, coming for the different types of the motors we are using, I'll not deeply go into the motors today. Tomorrow we'll deal with the motors and all. Today, what I can say is the major motors we are using in case of the BLDC, in case of the electric vehicles, one is a BLDC motor, next is the permanent magnet synchronous motor, and the next is the induction motor, and lastly we'll be having something called our switched reluctance motor. From all these motors, the BLDC motors will be widely used in electrical two-wheelers and all, where they'll be having the feature of some hub mechanism. No need to worry. In detail of the motors will be explained for you people. Then we'll be having something called our permanent magnets motor, permanent magnet synchronous motor. These are the motors from the family of synchronous motor, where we'll be having the proper synchronization between the rotating magnetic field and electromagnetic field which is created by the permanent magnets. Due to this synchronization, these are also one of the most used motor types, I can say. Then induction motors, where they are one of the favorite motors for the electric vehicle manufacturers or electric vehicle assemblers, where they always try to choose the electric three-phase induction motors. Because it is very, very easy to control the three-phase induction motor, where I can easily control the speed of the motor just with the variable frequency drive. If I change the input frequency, I can control my motor very easily. Then I'll be having something called my switched reluctance motor. So these switched reluctance motors are, as of now, we are not using any you are not using in any vehicles, because they'll be having some noise issues and all. Why the noise issues and all, everything we'll discuss in the further sessions. And coming for the charging ports, same as your mobile phone, you will be having the charging ports for the electric vehicles, where you can charge your vehicles. Coming for the different types of the charging ports in the market, these are the charging ports where you will be having in the Northern America, where the plug name is J1772 Type 1. The same with the Japan. And whenever we are coming for the AC, these are the things we'll be having. And whenever we are coming for the DC, we'll be having something called our CCS1 in case of the North America. Coming to the Indian scenarios, for the AC, we'll be having something called our Commando Type 1 IEC 60309 variant, and one more variant we'll be having many case. And whenever you are coming for the DC, you will be having CHAdeMO type of connectors and all. You'll get to know what is the use of this and all. Just I'm trying to recap. Just I'm trying to give the quick summary of the things. And the next one of the important thing in case of our electric vehicle is auxiliary batteries. One of the important things we'll be having is auxiliary batteries. So whenever we are dealing with the auxiliary batteries, so auxiliary batteries are something that which will be working as a secondary batteries, where you will be having the low voltage levels, and for the low voltage applications, in generally we'll be using these auxiliary batteries. Okay, and we'll be having something called charging system. The charging system for the auxiliary batteries can be done with the help of the regenerative braking, or while you are or whenever you are connecting, or whenever you are trying to charge your main traction battery, at the time also this auxiliary battery will get charged. Okay, yeah. So this is the small thing is your auxiliary battery, which is connected for the auxiliary systems. Okay, now comes the disadvantages. Now all of you clear with the components, everyone? Everyone clear with the components? See guys, I'm asking some question. Don't put any your response sheets in the chat box. Even if you just open the link and you can easily fill that link. There is nothing new in filling the link. No problem. No need to inform while you're no need to inform that if you are filled or not. The point I'm asking is everything clear as of now? What I have discussed regarding the points and all regarding the components. Yeah. Everything I'm getting the clears. Okay, I'm happy to hear listen. Chalo. So here comes the major disadvantages as we discussed. So in generally, yeah, someone is asking to explain the auxiliary batteries. Okay, see here, this is the traction battery. Okay, the voltage level for the traction batteries will be very high. Okay, so in the vehicle, not only the motor, there are some other electrical components we'll be having, such as our bulbs, such as our lights, such as our sensors and all. So they need to have nearly 10 volts, 15 volts, 12 volts. Okay, so if I connect this 300 volts batteries to that 10 volts or 12 volts, then automatically they will get damaged. Okay, so instead of using this, one thing I can use is one of the extra battery that is known as my auxiliary batteries, which I can give power supply towards my auxiliary system. Okay, towards my auxiliary components. Okay, I think I'm clear. Arun? Yeah. Sure. Now, before going into the further, one thing we have seen is disadvantages of the electric vehicles. So most of the people given the same common answers, where all the answers are very, very appropriate. I appreciate you people's effort and all. The way you searched on it and all, everything I can appreciate you. Yeah. Now, whenever we are coming for the disadvantage, see, the point is that one thing I have mentioned in the early stages that electric vehicles still in the R&D segment itself. So whenever we are dealing with R&D, in the R&D, people will not call the disadvantages. They'll be generally calling the scope of improvements. Okay, people generally calling the scope of improvements. Now let us see the topmost scope of improvements where the batteries, where the vehicles need to do, or where the R&D segment, or where the manufacturers, assemblers need to concentrate. The one thing we'll be having is limited range and long range difficulties. So this is the thing most of the people are also mentioned. So whenever we are coming for the limited range and long range difficulties, yeah, whenever we are coming for the limited range or long range difficulties, the point yeah. So here the point we'll be having is in generally we can't travel for the higher distances in case of the electric vehicle, where I can call it as the range anxiety we'll be having. But I said that is the scope of improvement. So that is observed by the EV segment people, that is observed by the EV market people. Now they are bringing up with the new variety models where initially we'll be having the 200, 300 range. Now those vehicles are came up to 500, 600, 585, 685, if I'm not wrong. So the range of the vehicles are increasing. Okay, so this is one scope of the improvement, and where the scope of the improvement is also happening. And then we will be having something called the long time charging. Yeah, this is one thing where we need to focus, because we generally don't have patience. Okay, so imagine if we are going for the petrol bunk. So if there is a line in front of us where we'll be having the 4 or 5 vehicles, we don't even wait for that 4 or 5 people completes. Okay, we'll keep on horn, or just simply we'll skip from that filling station and we'll move into the next consequent filling station. So this is what the patients in generally will be having. But whenever we are coming for the electric vehicle charging, base variants itself taking nearly 6 to 7 hours or 7 to 8 hours if you are charging at home. And even though if you are going for the proper charging stations also, you need to wait at least for 1 hour or 1.5 hours. So this is one of the major disadvantage with respect to the EV charging segment. This need to be improved. And for this, we'll be having few technologies where we can also implement the supercapacitors and all that the R&D is going on, where it will also bring the scope the people who are looking for the R&D in case of the EV. Then one more thing, even though if the charging time is high, even though if we are interested to wait also, there are very, very less charging stations, which I can say that the charging stations are very, very spare. Okay, there is a spare in the charging station. Okay, very less charging stations we'll be having. So charging stations need to be improved. And here, one thing I can say where you can also, where you can also have the proper where you can also have the proper business idea here. If anyone is looking to be the entrepreneur in the EV segment, you can establish the charging stations where the subsidies are given by the governments if you are having the proper land. So you can be the entrepreneur in this segment. And the next one of the major thing here, in the charging time, you can have your meal or you can take the break from driving whenever you're having the long journey. Imagine some of the person met with the accident and you're going in your vehicle. So the charge is completed. Then you'll wait in the charging station for 2 hours and you'll have the meal until the person dies. No. So we should not think always regarding the long journeys only. Yeah, we may have different conditions, but this is by default the disadvantage. We need to agree with that. Okay. Then we'll be having something called one more major scope of improvement need to be done is battery cost is very, very high. Okay. So this is the thing I'll also agree. The battery of one of the major or one of the costliest equipment in the electric vehicle is battery itself. If your battery damages, rather than buying the new battery, you can buy the new electric vehicle. Okay. So this need to be reduced. Okay. Because the point what I can say is, most of the people are interested to buy the electric vehicle because of the cost. They are being one step back before buying. Okay, I can say you one example that I think all of you are aware of the Bangalore city, where we'll be having most of the educated people, most of the IT employees will be having. So one of the survey conducted in the Bangalore, which the question is asking, which the asked question is, are you interested to buy the electric vehicle? If I'm not wrong, 85% out of 100% is said they are interested to buy the electric vehicle. And one thing they have again asked is, what is the thing that's stopping to buy the electric vehicle? The only thing they said that the cost of the vehicle is very, very high. So we need to reduce the cost of the vehicle. One way to reduce the cost of the vehicle is definitely we need to reduce the cost of the battery. So these are the scope of improvements as of now we'll be having in case of the electric vehicle technology. Am I clear for everyone? Am I clear for everyone? Everyone is following. I'm not getting much SS. I want everyone need to be responded. Rest should be like the rise in the stock market. Okay. Yeah. Okay. Shall. Now coming back to our topics. Some people are posting the doubts. In the last we can discuss regarding the doubts. Yeah. Chalo. Now the next thing, yeah, the things as of now we have discussed is regarding the IC engine vehicles, and we have seen the things regarding the electric vehicles, if I'm not wrong. Am I correct? These are the things we have discussed. We have seen the IC engine vehicle things. Then we have seen the electric vehicle things. Chalo. Done. Yeah. So we have discussed regarding the IC engine vehicles. Is this the IC engine vehicle we have seen? Where I'll be having my fuel gauge, which is connected to the engine, and then I'll be having something called my transmission. Is this a thing I have seen in case of my IC engine vehicle, if I'm not wrong? Yeah. Then this is the one we have seen in case of the electric mode, where I'll be having my battery, I'll be having my motor or generator set, then I'll be having something called my transmission. Okay, if you properly compare this, the transmission will be one and the same in case of your EVs and normal IC engine vehicles, where you'll be having some difference in the manual gearing and automatic gearing. That is something different story. The transmission, the end goal of the transmission is to supply the mechanical power. Now, whenever you are coming for the power source, the major difference comes here in case of the IC engine and electric vehicle, that the major source comes at the power source. So here for the power source, in case of the electric vehicle, I'll be having something called a fuel as my power source. My vehicle will be running on the fuel power. And then I'll be having something called my battery as my power source. Here my vehicle will be running on the battery segment. Here my vehicle will be running on the battery segment. Battery is my power source. And coming to the conversion, the fuel's chemical energy is converted into mechanical energy with the help of the engine. And the same in case of the electric vehicle, the batteries DC electrical power will be converted into different sorts of mechanical power with the help of the motor. Okay, so these are the things we have seen. Now here comes the major point. Okay, now what happens if we combine both the energy sources? Is it possible to combine? If yes, what happens? Yes. Hybrid. Okay. Hybridization of energies, hybridization. Yeah. So whenever I listen the word hybrid, one dialogue I'll remember from the movie Liger. I think, yeah, no need to say that many times hybrid, Dinesh. One hybrid is enough. The hybrid itself saying that the combination of two things. So if you are from if you are watching the Telugu films and all, we'll be having something called one movie known as Liger, where the hero will be saying that the liger is a combination of lion and tiger, which is a hybrid. Okay, so here whenever we are coming for the automobile industry also, see, the point is that we may have the drawbacks in case of the IC engine vehicles, but we can't completely take off the IC engine vehicles. And we can't even completely depend on the electric vehicles, because the one is the existing technology, one is the growing technology. So we can't keep existing technology completely aside, or it is not possible to keep it completely aside, because it will take some time. So the point is that until the complete automobile industry is converting into the electric vehicle industry, so by then we'll be having at least 50% reduction of the pollution can be done with the help of one method, that is your hybridization method, where if I can properly connect my if I properly combine my electric vehicle with the IC engine vehicle, then one of the new technology that introduced is the hybrid electric vehicle, in which I'll be having a proper battery system, a proper engine system, where my vehicle will be running based on the road conditions, based on the degree of hybridizations, based on the drivetrain configurations, based on the type of the segment we'll be using. Based on that, the vehicle will be running. Okay. Now, if we properly analyze this, yeah. Now, if we properly analyze this system, what an IC engine consists of fuel and engine. Then what an battery consists of? Batteries consist of our motor and generator. Then the next thing is what happened when we what do we get when we add both the systems? We will get the HEV, that is the hybrid electric vehicle. Now, in case of the hybrid electric vehicle, I'll be having the battery fed vehicle, then I'll be having the fuel fed vehicle, where my vehicle will be properly running on both the energy sources. How and all you will get to know. So this is the block diagram or something I can say in case of my hybrid electric vehicle, where in case of my hybrid electric vehicle, my what we say, fuel gauge is refilled with the help of the external fuel coming for the batteries. Here the batteries are only recharged with the help of the regenerative braking. Okay, here the batteries are only recharged with the help of the regenerative braking mechanism. Okay, yeah. So now you people may get doubt that sir, can't we charge our batteries externally? Do you get this doubt? Can we charge our batteries externally? Yes. What about the remaining people? Yeah, no, yes, no, yes, yes. By solar, by, yeah, we will be having the different options. Yeah. Yeah, very good. Based on the powertrain configuration, we'll be getting the clarity regarding this. So now, before going into the powertrain configurations and all, no need to go until the powertrain configuration. Just in the next slide, I'll explain you people that if you properly look out the different variants of electric vehicles, there itself you'll get the clarity. See, the point is that whenever you are combining both the energy sources, you will be getting the hybrid electric vehicle. Hybrid electric vehicle will be having only regenerative braking, but there is one more variant in the hybrid electric vehicle, that is the plug-in hybrid electric vehicle. Okay, whenever we are coming for the plug-in hybrid electric vehicle, this is the system. See here, if you properly check that hybrid electric vehicle will be running on the liquid fuel and battery. Plug-in hybrid electric vehicle is also running on the liquid fuel and battery. Coming for the battery powered electric vehicles, they'll be running only on the battery power. Coming to the fuel cell electric vehicle, they'll be running on fuel cell and battery, which you'll get to know whenever I'm dealing with the battery technologies and all. Now, let us majorly focus on the three types of electric vehicles. One is hybrid electric vehicles, one more is a plug-in hybrid electric vehicle, and one more is the battery electric vehicle. Now, let me explain. So this is how your three modes of vehicles you will be having. One is the hybrid electric vehicle, where my vehicle will be running on both gasoline engine and motor. But here the battery will be recharged only with the regenerative braking mechanism. Okay, so this is what the hybrid electric vehicle looks like. This is the case of the non-plug-in hybrid electric vehicle. But whenever you are coming for the external source of hybrid electric vehicle, those are known as the plug-in hybrid electric vehicle. They are your PHEVs, plug-in hybrid electric vehicles, where the only difference between your hybrid and plug-in hybrid is the batteries are recharged with the help of the external power source also. Okay, here whenever you are coming for the normal hybrid and plug-in hybrid, the capacity of the motor, the capacity of the battery can be increased, because in case of the normal hybrid, only 30% of wastage energy can be utilized. But whenever you are coming for the plug-in hybrid, along with the 30% of wastage energy, you can also recharge your battery full-fledged from the external power source. Okay, so this is in case of the plug-in hybrid electric vehicle. And the one more variant is your battery electric vehicles, where properly we can properly have the battery mode of electric vehicles. We'll be having only battery and motor. Here the batteries can be recharged with the help of regenerative braking along with the external power source. Okay, so this is about the different energy sources we'll be having, or the different types of electric vehicles we'll be having. Okay, I think I'm clear for everyone. Now I'll be moving into the further. Yeah, how do we refuel the normal hybrid vehicle means? Here you can get to know that hybrid batteries is charged only with the help of the regenerative braking. Generator that is powered by IC engine vehicle, where we'll be using the generator mechanism or motor or generator set we'll be using, which will be converting the electric power into mechanical power, and mechanical will be converted back into the electrical and given to the battery, which is your regenerative braking mechanism. Or if you want to charge it externally, you need to go for the plugging in mechanism. Okay, so this is what regarding your hybrid electric vehicles. Okay, so here you will be having the hybrid electric vehicles. This is how your hybrid electric vehicle will be look inside. Okay, and this is how the plug-in hybrid electric vehicle looks like. The only change we'll be having is here we'll be having only fuel gauge. We don't have any charging point. You may ask that, sir, that side it may be there. No, that side also you can't find that, because this is the hybrid mode. Then whenever you are coming for the plug-in, here along with the fuel, I'll also having the external power source. Now that side there is external power source, where you can see, because I'm presenting only 2D picture, but in case of the plug-in hybrid, you can connect the external charger. Okay, yeah. So this is the other direction of the picture, where the person can charge the battery, or there will be the connectors which you can connect the battery to the power source. Okay, yeah. Now here, whenever I'm dealing with these hybrid electric vehicles or plug-in hybrid electric vehicles, we'll be getting the doubt that how we need to identify the contribution, or which mode of hybrid vehicles will be having high motor power compared to IC engine. Okay, so for that we'll be having something called the degree of hybridization, where the degree of hybridization is calculated by electric motor power divided by total power. Okay, so total power, which includes electric motor power along with the IC engine power. So in case of the degree of hybridizations, you will be having the micro, mild, fully and plug-in hybrid electric vehicles. So whenever we are coming for the micro hybrid vehicles, majority of the vehicle will be running by the IC engine. Here the motor will be acting as a backup, where the motor or the electric segment will be only useful for starting of the vehicle or for the regenerative braking. Whenever we are coming for the mild hybrid vehicle, these type of hybrid vehicles we can use for some starting operation, and we can also use for low speed application, where the capacity of IC engine will be reduced as compared to the previous case. Now, whenever we are coming for the fully hybrid, here the majorly vehicle will be running only on the motor. Here the IC engine will be acting as a backup. The complete vehicle will be running on the motor power, and the same with the plug-in hybrid electric vehicle. Okay, the only thing we'll be having difference between the fully hybrid and plug-in hybrid is, in case of the fully hybrid, we can't charge it externally. In case of the plug-in hybrid, we can charge it externally. Now, these are the things we will be having in case of the micro, mild and fully hybrid. Automatically start or stop mechanism you can do with the help of the micro hybrid. The same you can do with the mild hybrid. Along with that, you can also use a regenerative braking mechanism, and also you can use as the electric motor assistance. you can also use as electric motor assistance. Whenever you are coming for the fully hybrid vehicles, along with the three discussed thing, you'll also having the car can drive at a time using only electric motor itself. And whenever you are coming for the plug-in hybrid, one more advanced feature we'll be having is external charging technology. So this is how your vehicles will be running. This is how the contribution of vehicles will be done. Am I clear regarding the types of EVs and degree of hybridization? Clear for everyone? Can you quickly type S in the chat box? I'm getting very less SS. I want yeah. Now coming to the drivetrain configurations. Okay, so as of now we have discussed we'll be having the series and parallel mode of hybrid vehicles. So once I explain the drivetrain configuration, I'll end the session for today and we can go for the doubt session. Okay, just within 5 to 10 minutes the session will be ended. Can everyone see my screen? So whenever we are coming for the electric vehicle, we'll be having a hybrid electric vehicle. We'll be having two power sources. One is the hybrid, which is electric motor and electric motor fed vehicle or battery fed vehicle, or one more you will be having combustion engine fed vehicle. Or a petrol fed vehicle or fossil fuel fed vehicle. Now, whenever we are having the two substances, we need to combine them. Okay, whenever we are trying to hybridize them, you can hybridize them in series, in parallel, as well as in series parallel. So these are the three methods where you can classify your electric vehicles or hybrid electric vehicle based on their drivetrain configuration. So coming for the drivetrain configuration, the first step we will be having is series hybrid vehicle. Okay, here you need to be more clear, or here you need to be more conscious that what is the output power I'm getting from the engine? What is the output power I am getting from the engine? Quickly, you need to respond. Mechanical, very good. So the output power here I am getting from the engine is mechanical power. Okay. Now, whenever I am giving the mechanical power for the generator, what happens? Whenever I am giving mechanical power for, yeah, very good. That mechanical power is converted into the electric power. Okay. Now imagine the electric power you are getting from the generator is E1. Okay. Let us understand that the electric power you are getting from the generator is E1. Now, what is the output power you are getting from the battery? Electrical. Okay. We are getting the electrical. Now, this electrical power I am getting is the E2. Okay, that is my electrical power 2. Now, whenever I am combining both this electrical power 1 and 2, what is the power output I will be getting from the power converter? Yeah, electrical power, which is combination of E1 and E2, if I am not wrong. So just imagine roughly from here I'm getting the 2 amps. From here I'm getting the 2 amps. The output here I'll be getting the 4 amps, which is the combination of 2 plus 2. Okay. Electric power 1, 2, I can say 2, 1, I can say. Okay. Now, if I'm giving this electrical power to motor, what happens? Yeah, I'll be getting the mechanical power output here. Then from the motor, I'll be giving power supply towards my vehicle. Now, if you properly analyze here, the mechanical power which I am giving for the vehicle is the combination of electrical power given by generator and electrical power given by battery. Or I can say that the mechanical power which helps to rotate the vehicle is the power is the combination of engine's mechanical power and the power converted which obtained from the battery. Now here I am using two power sources at a time? AC and DC is something different story where I'll be using the multi-level converters and all. So that is not bigger task. Okay. Yeah. The point is that what is the power I'm giving for the vehicle? So for the vehicle, I'll be giving the mechanical power. So is the mechanical power is combination of power which I'm getting from the engine and the battery? Am I correct? Yes or no? Yeah. Yes, yes, yes. Okay. How I'm connected this? How these both the powers are connected? Are they connected in series or parallel? Yeah. So this is known as the series hybrid vehicle where I'll be using both the power sources simultaneously. Here I'll be using uh, both the power sources simultaneously. Okay. So this is one of the base model where you can take it as a basic example. In the real time, you'll be having a proper connections and all in between, you'll be having the proper things you will be having. So this is your series hybrid vehicle. So whenever you are dealing with the series hybrid vehicle, the major disadvantage with this method is here you need to convert the power once. Here you need to convert the power twice. So whenever you are trying to convert the power continuously, the efficiency of the power will be reduced. So this is one of the major disadvantage with the series hybrid vehicles. And this is in generally used for heavy vehicles. This is in generally used for heavy vehicles or military buses and all where we'll be using, which can run on low power, low speed applications where there will be using the series hybrid. Okay. Now the next thing is parallel hybrid. So once you get the clarity regarding the series hybrid, I don't want to go much into the parallel hybrid. So from the engine, I'll be getting the mechanical power. From motor, I'll be getting the mechanical power. Based on the road conditions, I'll be using either engine's power or motor's power. Okay, here I don't have any conversion losses. Torque is directly supplied towards my wheels. Here the torque is directly supplied towards the wheels. Okay, and no generator is needed here. Okay, so this is what happened in case of the parallel hybrid. For the starting of the vehicle, I can use electrical power. For running of the vehicle, I can use the engine power. Okay, so any one of the power source I'll be using. Clear with the parallel hybrid? Yeah. And the next method, important method we'll be having is series parallel hybrid, where you will be having this system without the generator, this system individually acting as IC engine. This system without generator connectivity, it will be acting as an electric vehicle. Okay, so this is the parallel way of connection. If I connect the generator in between, it is working as a series way of connection. So here in case of the series parallel hybrid vehicle, I'll be having the series mode of operation. I'll be having the parallel mode of operation based on the road conditions I'll be using. Okay. So if I take an example here, initially, if I take the proper series parallel hybrid mode of vehicle, initially my vehicle will be running only on my vehicle will be starting only on the electric motor, where I'll be having the parallel mode of operation. Then my vehicle will be accelerating based on the electric motor and engine power, where I'll be combining both the power sources, which will be having something called our combination of both the power sources, where we'll be having it will be working as a series hybrid. Then again at the top speed or the high speed cruising, it will be running only on the engine. It will be acting as a again, it will be acting as our parallel, or it can also act as a series where we will be having the proper regenerative braking mechanism. Then while the decelerating, engine will be turned off, or engine will not be in connection with the vehicle. So here it will be working only for the battery, where the regenerative braking mechanism will be happen. So whenever I stop the vehicle, I don't have any source of power. So this is how I'll be having the series parallel, where in one vehicle I will be using series mode of operation, as well as I'll be using parallel mode of operation. Okay, clear? Yeah. Finally, yeah, the session timings will be 7 to 9 if I'm not wrong. Yeah. Yeah. This is how we'll be having the series parallel mode of vehicle. Okay, I think you are clear with the series parallel mode of vehicle also. Then something we'll be having are different types of electric vehicles. We will be having in the market. We'll be having in the market are the electric vehicles based on the BEVs or battery electric vehicles. We'll be having the Tesla and all. Whenever we are coming for the hybrid electric vehicles, we'll be having the Toyota, Honda, and different brands in the Toyota. Where if you want, you can also make a research on it. So whatever the vehicle they are using, which type of technology they are using, you can easily identify here. Am I clear? So if you want, you can also have a snapshot of this slide where if you see the vehicle, you need to remember which type of vehicle is this. Okay, you should not feel like he's roaming in bench when I'll be roaming in the bench car. Okay, the point is that what is the configuration they are using, what is the drivetrain configuration they are using. We need to analyze that. If you properly analyze these things, definitely one day you'll also roam in the Mercedes. No need to worry. Okay. Yeah. Then we'll be having something called these are regarding the vehicles. Lastly, I'll be ending up in 5 minutes. This what is the car made up of and all. In tomorrow's session, we'll be dealing. So by this, I'll end the session. I think everything is clear from my side. Everyone understood whatever I have said. Yeah. Yeah, sir. The future of EVs. Yeah, I think Ganesh, you are asking the same question since yesterday. So because of the time lapse in the yesterday's session, I failed to answer your question. The thing you are asking is the future of EV. The future is EV. Due to some weather changes, there is difficulty to serve them. Can you explain that? Okay, this is what your question. Okay. Yeah. I can say that you are touching one of the important concept where we'll be having the weather related performance issues, and we will also having the weather related service challenges whenever we are dealing with electric vehicles. One thing we'll be having is the cold weather issues because whenever we are running our electric vehicles in the cold weather, then automatically we will be having the reduced efficiency, and whenever the temperature is not up to the mark, we'll be having the charging issues, even in case of the cool charges or in case of the cold weather or hot weather. If your battery or if the external temperature is very high, you should not go for the fast charging. Okay, and whenever we are coming for the hot weather challenges, we will be having the battery degradations, and we'll be having the stress on the charging stations, stress on the chargers we'll be having, and we'll also having some service and infrastructure problems. Despite all these charges, the companies are developing nowadays. The companies are properly developing all weather condition batteries, and they'll be having the better insulation along with the adaptive thermal system. They'll be having the proper battery management system also, where the vehicles can properly resist for all the conditions and all the conditions in Indian scenario or whatever the scenario you take, they can resist. Am I clear for your doubt? Yeah, someone is asking that if we don't use the battery for 3 months, will they drain out? Yeah, see, the point is that I can say they'll be drain out. For that, you'll get the proper clarification while I am dealing with the battery system, because for the batteries also, you'll be having the self-discharging rate. And the point is that if you are storing your battery in 50% of state of charge, then they'll not properly discharge, or then they'll not have the self-discharging issues. But if you are abnormally charging them and abnormally discharging them, then definitely they'll be having issues. Yeah. I'm clear from my side. Now the session is open for the doubts. BHEV not, it's a BEV, battery electric vehicle. And next is the FCEV, fuel cell electric vehicle. They are not the BHEVs and they are not the BHEVs, they are the BEVs. So can you realize from there? From where I need to realize? Tilak, first you raise your hand, then I can unmute yourself, unmute you, because it's very much difficult to find the Tilak in the entire system. Yeah, at the time of manufacturing, we will be having the problems regarding the pollutions. While we are manufacturing the batteries, we may have the pollution problems. But if we compare the pollution of the manufacturing and the running pollutions of IC engine vehicles, they are very, very, very less as compared to the running pollution of the IC engine vehicles, where we can easily identify that. We can easily keep it aside. Okay, there is no need to concentrate that because. See, the thing is that if you are using the IC engine vehicle, the complete system will be getting damaged. But if you are making the batteries, there is a very, very small amount of system will be getting damaged. So comparatively, we can use that. No need to worry. Yeah, someone is asking which conduction mode will be using in case of the inverter when we are using the inverter. In general, we'll be going for the continuation conduction mode or discontinuous conduction mode. Okay, and in few cases, we can also go for the boundary conduction. Yeah, someone is saying that someone is asking one joke. Someone is asking one question that these batteries are more pollutant than the fuel burning. It's completely a myth. Someone is misguiding you. The thing what I can say is the initial impact on the battery manufacturing may be higher, but the long-term impact created by IC engine vehicles are very, very high. Okay, so on the bottom line, I can say that battery manufacture can initially more dangerous from an industrial and environmental standpoint, but coming for the running conditions, you don't have that, you don't even have any pollution. But in case of the IC engine vehicle, they'll be consistently giving the pollution. Okay, so if that is the difficult one, government will not allow that, if I'm not wrong. Then these batteries are more pollutant. No, I'll not agree. Tilak, any doubts from your side? I think you're asking someone about something. Sir, is there any devices when the car gets major crashes? So which type of devices? There will be the sensing devices, and nowadays those sensing devices are they are even connected for the safety operation SOS. So by that you can protect. Okay. Yeah, someone is asking that, sir, what about the Hammer 4x4 EV? That is not Hammer, and that is the Hummer. HU, you need to do. Whenever you are coming for the Hummer 4x4, you will be having the full-time 4x4 vehicles where you will be having the proper locking differentials, which will be majorly working as your all-wheel drives. Yeah, for every vehicle, you will be having the decomposition issue, and even for the IC engine vehicles also, you will be having the lifetime. For the batteries also, if I'm not wrong, they'll be giving the 7 years of the warranty on the battery. So that is more than enough, if I'm not wrong. Tilak, you're asking something of the 5 days section. I think if to be precise, it is you're asking about the 5 days of sessions. EV produce e-wastage. See, the point is that whatever the wastage it produce, whatever the pollution it creating, that is just 10% of the IC engine vehicles. So no need to worry. Yeah, one good question I have seen that our power is majorly 60 to 70% of the power generation is from the coal. Then because of the coal extraction also power is getting increased. For that you can also go for the renewable sources like your solar and wind turbines, where you can also connect the solar for the charging stations where the power is generated with the help of the solar. You'll be having the proper renewable source. Om Prakash, I have already explained regarding the technology what you are asking. That is not Hammer, that is Hummer, where you will be using the proper 4x4 with the interlocking of the drive system. Yeah, regarding the batteries and all, you will get to know. Let's wait and see. Yeah, I have already discussed the disadvantages with the electric vehicles, and I have already intimated you people don't call them as the disadvantages, just call them as the scope of improvements. See, we will be having the problems and all. See, for your questions, you'll Purna, you'll get to know while you are designing the inverters and all. I think you need to wait for a few more sessions. Then anything else, Andy? Which is the best electric vehicle at the time and which parameters we need to run? I can't come for one conclusion. You can go for the Tata, you can go for the Mahindra. Every electric vehicle is best according to me. And the major constraints you need to check, or major things you need to check regarding the electric vehicles are you need to check the efficiency, you need to check the range, and you need to check the battery capacity. So these are the parameters you need to check while buying the electric vehicle. What is the fuel cell electric vehicle? I think you are not following the class properly, Omkar. I have already intimated that you will get to know while we are discussing about the batteries. Yeah. So any further doubts, you can quickly type in the chat box, or else in 2 to 3 minutes, we'll wind it off. Charging of the batteries cost more. In that, we can buy a new vehicle. So Ranjit, I think you didn't attend it for the extra days class. Ranjit, can you quickly answer for my questions? Ranjit, are you there? Yeah, in the yesterday's session, I have discussed regarding the running cost. If you properly rewind that running cost, there you will be having nearly 10 times of the savage of running cost. So I think one example I can give is a liter petrol cost is 110 rupees. A unit current charge is just 5 rupees. So with that unit current charge, you can't buy new vehicle. If I'm not wrong, you can't even buy what we say pedal vehicle also. You can't even buy. Yeah. So I have some doubts regarding the PHEVs. I have noticed that regenerative braking is only for hybrid electric vehicle type. No, I have already said that the regenerative braking is also for the plug-in hybrid electric vehicle. Along with the regenerative braking, we'll be having the external power charging. EV does not have resale value, sir. Why? Because once the battery life is extended, once the battery life is extorted, the battery cost itself the vehicle cost. So you don't have the proper resale values. But whenever the battery life cycle is decreasing, after 5 years or 10 years, if you after 5 years or 6 years, if you are going for the new variant, you will be having the good resale value. Regarding the life, I can say the battery vehicles will be having the good life if you are using it properly. So I have one question this session recording. I'm not getting you, Tilak, what you're saying. So I have one question. This section going recording for clear. I'm not getting your question. Are you asking this session is recording or not? If it is, it says you can find the recorded one in the YouTube. Yeah, the same link you can use. You are trying to ask regarding the link, the same link you can use. Yeah, the point is that whatever the link you have used today, but the same link you can use for the tomorrow session also. If there is any change in the link, like today, we'll let you know. Anything else, Andy? Shall we wind it off? It's already 8:55. So it's time to say goodbye, or it's time to say good night.
Manjunath,
Yeah.
I think we are done with the session, right?
Yeah, we are done with the session.
Yeah, thank you, Manjunath, for your valuable time and insightful content. And
Yeah,
a big
okay.
thank you to everyone for your patience and participation. See you all tomorrow for day 3 of free masterclass. Thank you.
Yeah, thank you, Andy. Now you can leave.
Yeah.
Sure.